So for this one, we write down the term in XR. Okay, so when I look at just a general term for this expansion, I know it's going to be 12 choose R, some R. The first term I'm going to put to 12 minus R, and the second term, which is minus BX, I'm going to put to R. So that way I've got X to the R happening here. So the term with X to the R in it has all those things. Alright, write down the term in XR in the expansion. So when I then times that by 1 plus x, I want the coefficient of x to the 8, apparently. Alright, so if I take that and times by 1 plus x, if I'm looking for the coefficient of x to the 8, if you think about this, so I could times whatever so I could put r equals 8, and then that would give me, times 1 would give me x to the 8. So I could have r equals 8, in which case we would have 12 choose 8, a to the 12 minus 8, and then minus b to the, I'll separate these out, to the 8, and then x to the 8, or, so plus, the other thing I can have is if I times all this by x, in which case I would only want x to the 7, because that's timesing by x. So I would have 12 choose 7, a to the 12 minus 7, and minus b to the 7. Okay, and this coefficient's 1, so that's all fine. So I'd get that. Now, if it tells me the coefficient of that, which is that, is equal to 0, let's make it to 0. Find the value of the ratio in simplest form. All right, so let's have a look at this. We know 12 choose 8, blah, 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 has to equal the negative, and there is a negative here, so that makes it nice. So if I put the 12 choose 8 part on the left, keep it on the left, I'm going to have 12 factorial on 12 minus 8 factorial, 8 factorial, a to the power of 4, and negative to the power of 8 is positive, so I'll just put b to the power of 8. And that equals, so I'll put all this on the other side using that negative, negative to the power of 7. So because it's going to be on the other side, it's now positive. So 12 factorial on 5 factorial, 7 factorial, so 12 minus 7, and 7 factorial, a to the 5, and b to the 7. Okay, because the minus cancelled, I put it on the other side. Now, if we look at that already, they both share 12 factorial, so we could divide both sides by 12 factorial, for instance. And then I could put my 5 factorial on the top, so I'll just multiply these both across for a second, 5 factorial and 7 factorial, and you can see 5 factorial is 5 times 4 factorial, so there's only going to be a 5 left there, and then 7 factorial on 8 factorial, there's only going to be an 8 left there if we simplify that. Now if I keep the b's on this side, I've got b to the power of 8, and if I divide by b to the power of 7, that'll just be a b. And if I put the a's on the other side, I'm going to have a to the power of 5 divide by a to the power of 4, which is just an a. So if I want the a on b, the ratio of a on b in simplest form, you can see it should be 5 on 8.